Okay, this is a quick look at my tap water battery. It has nothing but tap water in it, and the tap water here is directly out of the lake, and it's not heavily chlorinated or anything like that. It's glacial fed, so it's people in other areas of the world that have chlorine in their water will probably get better results. So the history, or the reason that this cell came about, was I wanted to make a cell that would last a fairly long time. With copper and zinc, the redox reaction reaches equilibrium quite quickly, after about 4 to 5 days from my experience, and so I wanted to retard the rate of that reaction. And so it seems that stainless steel and zinc was the answer. I discovered stainless steel and zinc have quite a large voltage potential difference by accident when I've got some stainless steel rods here. One of them rolled onto my voltmeter needle and I got a voltage, and so I decided to make cells up. On straight tap water I get about 0.7 to 0.8 of a volt per cell. If I use 50-50 mix of Coca-Cola and water, or vinegar is probably better, I get 1.2 to 1.5 volts per cell. And so I've hooked these up in a serial connection, and I should get about 10 volts. This has been sitting for about an hour, and a quick volt reading there shows, oh there you go, 10 to 11 volts on my crappy voltmeter. This is a look at another of my tap water battery cells. It's made up of stainless steel washers and zinc washers, just one for one. The construction was a stainless steel bolt with electrical tape wrapped around it for insulation. One stainless steel washer on top. Then I cut out an absorbent washer, or a porous washer. This is car chamois material. It's supremely absorbent and really good for this use. So that goes on top. Then stainless steel washer on top of that. So that's one cell, and soaked in an electrolyte that gives me about 1.3 to 1.4 volts. In water a little less. So that's the cell there. I've just got paper clips on the end, and I'll give you a quick voltage reading. It's about 9.5, 9.6 volts. And in terms of work done, you can see that on the lead. Okay, it's just a cheap tacky lead. I've rewired the tap water battery into a mixture of parallel and serial series. Essentially I have 3 cells, 1, 2 and 3, and they're linked in parallel. The voltage I'm getting is about 4 volts. And this is a LED light. There you go. Just a cheap little LED that I had. And this is a torch. Okay, not bad for just tap water, and in fact I think that'd be enough to send messages.